Hello everyone, and welcome back to a new video in programming the finite element method using MATLAB. Now in this video, we are going to continue our efforts in the analysis and especially in preparing the structure model, because inside the perform linear elastic analysis, there are 5 methods which we need to populate, and one of them is the prepare structure model. We still haven't touched the clear structure model because it doesn't make sense now. We need to know exactly what we defined so that we understand what we need to clear. So for that, I will have to wait. We now will focus on the preparation of the structural model. Now, of course, if you're wondering, this is part of a bigger video series talking about the finite element method with a playlist linked above, and another playlist I will be linking above about the programming only, if you're interested in the programming aspect only. Notice that my dear channel members have access to the source code of every lecture. However, if you're not a channel member, then don't worry, because in the end, every single line will be written in front of you and you can write along and will have the exact copy of my own code. So today we're gonna prepare the structural model. I will explain what this means and maybe program me some things about this. So with that being said, I hope you enjoy. So sit back, relax, and enjoy the show. Now, we have only lines in our structural model. It would be a different ballpark if we had plates, but I'm limiting myself to lines. So let's program lines. In the creation or the preparation of the structural model, I would need to check line cross line intersections if those exist. So I need to create str nodes from line cross line. So if there is an intersection of lines, I am going to create structural nodes from this intersection. Now, I declared one function. You could have other functions, like, for example, line cross plate and plate cross plate, and so on. But I only have line cross line intersection, so I'll keep it like that, which means, yet again, I need another function. So function, create. Now, if you're wondering why I keep functioning things, I keep functioning things because I kind of like writing in piecemeal. This is easier for debugging purposes. So how would I create the line cross line? To create the line cross line, I would need to take every single line and compare it with another line and see if they intersect or not. Meaning, I would first of all give a for loop and give an index I equals 1 all the way to I equals the length of the str lines. I think it's called str lines, right? Is it the case? Let's check. In the properties, let's check what they are called. They are called str lines. Yeah, so the name is correct. It's been a long time since I touched those, so I forgot. Now I remember. So from 1 to length of str lines, here I'm gonna basically fish me out one line. So I call this str line 1 or just line 1. This line 1 is gonna be fished out of the str lines at the I. So I will, for each I, I'm gonna fish out one of those str lines. Now I need to intersect it with another str line. So I need to run another loop for j equals from 1 to the length of str lines to get the second line. And here in this case, line 2 would be str lines of j. So we have 2 lines now, and we are going to test the intersections of those 2 lines. Now the first thing that you need to check is you cannot intersect a line with itself because it doesn't make any sense. We want to intersect lines with other lines. So here, there must be an if statement. If line 1.id equals line 2.id, this means we have the same line, I would break out of the loop. Now here, of course, I'm missing object, so I'll just put here object so that we can access the str lines. I forgot that. Now here, I'm wondering, it depends on the programming language, but I'm wondering if break breaks out of all loops or only breaks out of the outside loop. Now there is only one way to find out, and I will push here the breakpoint, and I will see if it will break out of all the loops or only of the internal loop, because I needed to break out from the internal loop only. So let's just put it to the test and see what happens. I will run this thing, and there's an error, it seems. Let's take a look. Create str nodes line from line. I think I know why. I forgot to mention the object here when I defined it. Let's see. Yeah, I need to say object dot because this is part of the object. Now it works. Let's call for main again, and we're stopping here. Now here in the loop, of course, he selects line 1 and line 1 together. This is line with ID 1, and that's line with ID 1. So now, when I step, he should break out, and he breaks out of the internal loop. Perfect. This is exactly what I want to do. I will put here a quick comment to help me. I will say here, if we are comparing the identical line, or maybe put here, break because we cannot intersect with self. We cannot intersect the line with itself. Otherwise, here, I will say it is not itself, so check the intersection. I think break is not the correct one. I think I should say continue, because I want to continue testing. I actually do not want to break out of the loop. I just want to step and go to the next line. Let's try it again very quickly. I just had a small logic error. So now it's the same. It needs to compare the next line. So let's step. Yeah, now it compares line to right. Yeah, that's better. Well, that's going to be a little bit tough. Now, this might be the longest video of my video series. Okay, it is not itself, so we need to check the intersection. However, we need also to check if parallel. Because if parallel, there is no intersection. Now, how do I check if they are parallel? By simply making a cross product out of it and checking the length of the cross product. Because you know what the cross product is. If you remember from mathematics, when you take vector A and cross it with vector B, the answer is going to be a 3D vector of length 0 if they are parallel. Why? Because A cross B equals AB sine theta. And if two lines are parallel, theta could be 0 or 180, meaning that the answer would be 0. So the best way of finding if it's parallel is to make a check. So here, I will say are parallel and make the check. So here, I think this might be multiple lines in one. So I will say here, cross norm, and I will cross product Vx of the first line and Vx of the second line. So I will ask MATLAB to cross, and I'm going to cross line 1.vx with line 2.vx. This is going to give me the cross product. However, I want to check the norm of the cross product. I want to check the length of the cross product. Now this is the length of the cross product. Now I can check if it is parallel or not. Parallel means that the length of the cross product should be 0. Now there is no 0 in mathematics, in computer mathematics, because there are some numerical issues. I mean, you could write cross norm equals 0, but that's not really accurate, because you could land with a cross norm, like for example cross norm, that is like 0.00 something. This is almost equal to 0. So an equation with 0 doesn't work when you have finite numerical accuracy. So the best way of doing things here is to ask it to check if the absolute value of cross norm is more than our epsilon. Do we have epsilon here? Let me just check. Yeah, we have it. I think I should declare it constant. Let's for now not declare it. Maybe later I will refactor it. Since it's not constant, I must declare the object and ask it for the epsilon. So this means that it's not 0, but I want to test if it's 0, so I will test if it's less than objective epsilon, if it's a very small value. So if the norm of the cross product is a very small value, then I would consider them parallel and I'll just continue. I will not perform any intersection checks. Let me just put here a little comment. I will say here, continue, because we cannot intersect parallels. We reach this position where we say line 1 and line 2 are, first of all, not identical, so not itself, and second of all, not parallel. So this still doesn't guarantee an intersection, because this does not guarantee an intersection, because both lines could be skew. And if they are skew, they would fulfill all those conditions. Two skew lines in space are not identical, are not parallel, but they actually don't have an intersection. Now, how do I test that? It's a very, very, very long story that includes you understanding the principles of intersecting two space lines. I will write the code. You need to remember what the parametric equation of a line is. The parametric equation of a line, x equals x0 plus at, and y equals y0 plus bt, and z equals z0 plus ct. This is called the parametric equation, in which a, b, and c, or a vector made out of ai plus bj plus ck is the unit vector of the line, and x0, y0, and z0 are the starting coordinates of the line, or in reality, actually any coordinates on the line. This is called the parametric equation because you could assume any t, and from it you can calculate a point on the line. Now here, our idea of intersecting two lines in space is to find the t for line, because line number 1 would have its own parametric equation, line number 2 would have its own parametric equation, and our objective when we intersect line with line 2 is to find t for line 1, let's call it t1, and t for line 2, let's call it t2, such that the resulting coordinates on line 1 are identical to the resulting coordinates of line 2. You might have different opinions about that. This is pure mathematics. Like, the problem that we are trying to solve is finding the intersection of two lines in space. This is a geometry problem. You can Google it and search it if you want. However, I'm going to do my implementation right away. So now, let me give some values. Remember, A and B and C are the unit vectors of the line, and we do have the unit vectors of the line. You see, A1 equals line 1 dot Vx of 1, so the x component of the unit vector. B1 equals line 1 dot Vx of 2, that's the unit vector y of line 1. And C1 equals line 1 dot Vx of 3. So now, those for line 1 have been defined. I need to do the same thing for line 2, by the way. But before I do this, I need to go to x0, 1. I mean x0 for line 1. Now this, I need any coordinate on the line. Any coordinate. I can call for node 1, and for the x component of node 1, x or y0 for line 1, that's, well, line 1, I think I forgot to write 1 there, dot node 1 dot y, and z01 equals line 1 dot node 1 dot z. Fantastic. Those are the elements that are needed for the parametric equation of line 1. Now I need to do the same thing for line 2. I can just simply copy this stuff, and let me put here a comment to help me read it later. This is parametric equation line 1. And now I can basically copy this entire thing and switch line 1 to line 2. So let's see this in action. This is parametric equation of line 2. So now I have A2, B2, C2, and everything is 2. And I'm going to switch line 1 to line 2. Fantastic. Now we have the parametric equations of the two lines. Now we need to ask the question. We have to find t for the first line and t for the second line in the parametric equation, such that the resulting x, y, and z for line 1 and line 2 are identical. And this is where the skewness is checked. If they are not identical, then the lines are skewed. So how do I do that? Now this is a grueling task and a long task that is in mathematics. So what I'll be using my already developed code that I had in Strado that has been verified in Robot to make this three-dimensional check, or three-dimensional intersection check. This means that I will stop commenting because this is a 3D geometry problem, and I will just dish out the code. This also means that the editor might speed up the video. So if you want, you should slow it down if you want to write along. Alright, so I know if I have been programming very silently for like I don't know how long, depending on the editor, but now walk through the entire code. Now, as you notice, we have two lines and we need to get the parametric equation for line 1 and the parametric equation for line 2, something that I think I have mentioned before I started coding. Now this is stuff that is from pure geometric mathematics, so you need to brush up on those if you need them, and this code has been debugged before. I will check if this works later or not. Maybe I made a mistake, but for now, I've written it as I know from Strado. This is for line 1, and that's for line 2. Now here, there is a quadrillion of checks that you can see here, and those checks do have meanings. Let me explain to you exactly why we have 3 if statements. You see, the lines could be arbitrarily in space, meaning that they are not on the y in the xy plane, nor the yz plane, nor the zx plane. So if they are arbitrarily in space, then they are not parallel to any plane of those 3 planes, and any calculation would work. There would not be any danger of dividing by 0. Now, why am I saying danger of dividing by 0? Because if you can see from the calculations, there are some divisions that can happen here, and those could be 0. And especially those A1, A2, A1, B1, C1, and A2, B2, C2, they could be zeros. And sometimes you could have 2 of them zeros. Now, when does this happen? This happens when you have lines that are special cases. For example, if you have a line that is in the xy plane, then its own unit vector will not have a component on the z-axis, meaning that C1 would be 0. And if it's, for example, parallel to the x-axis, then B1 and C1 are 0. Now you see, since we are going to divide some stuff, we need to make sure that what we are dividing by is not 0, because those would be special cases. And that's the reason why I need to have all those things, all those checks. This, for example, I think, if I don't remember exactly correctly, But I think this checks if it is not in one of those planes. And of course, here I need to check which one is not 0, because I don't want to get a division by 0. This one checks another plane, if they are not parallel to that plane. And this one checks the third plane. So after all this work, we would be able to calculate T1 and T2. How do we do that, actually? The calculation of T1 and T2 is not really that hard, mathematically speaking. We have two equations that look like this. The intersection point is basically when equation 1 and equation 2 produce the same x's, the same y's, and the same z's. So the equation that would solve for T1 and T2 would look something like this. x0 plus x01 x01 plus a1 T1 equals x02 plus a2 T2. So the x that you get from the first line at T1 should equal to the x that you get from the second line at T2. Furthermore, y01 plus b1 T1 should equal y02 plus b2 T2. So the y you get from the first line at T1 must equal the line that you get from the second line at T2. And finally, z1 c1 T1 should equal z02 c2 T2. So the z you get from the first line at T1 should equal the z that you get from the second line at T2. Now here, the unknowns that you need to find are T1 and T2, and you have three equations to choose from. You only need two equations. But for a line arbitrary in space, not a special line, any two equations would work. But if you have lines that are parallel to something or perpendicular to something and all those special cases, then one of those equations will not help you because it's a special case. There would be zeros involved, meaning that you would, for example, let's say it's parallel to the xy plane, then C2 becomes 0, and this is no longer an equation. So there's a bunch of stuff that you need to take care of when you want to solve for those equations. So mathematically speaking, I need to check for all the special cases and choose or calculate using the correct case. In the end, all you see down here is just the calculation of T2 and T1 from using two equations from the three available. Now, once we calculate the T1 and T2, then I can actually find the x11. Then I can actually find the intersection point by applying T1 to line 1 to give me the XYZ components, and T2 to line 2 to give me the XYZ components. Now, one skewness check I must check is that this is supposed to be the same point, because the intersection point has been calculated by assuming x11 and x22 to be equal, because remember, this is the stuff we have done. We have equivocated, we made equal the x from the line 1 with the x from the line 2, y from line 1 and y from line 2, and z from line 1 and z from line 2. So this x and this x should be equal, and that y should be equal, and so on. However, I do check that. Now, the equality cannot be checked in computer math. You have to check that they are close to each other, meaning that the difference is less than a small value. Like the difference is like 0.0001 or something. Okay? Now, I did it differently. I said, if the difference in the x's is more than 0, or the difference in the y is more than 0, or the difference in the z is more than 0, then those 2 points are not the same. This happens if you have skewed lines. So in that case, just continue, don't do anything. If they are the same, then there is still more check. You would think, I found a point and they are the same, so everything is fine and nice and dandy. No, that's not the case, because the points you found must be on the line, not on the extension of the line, because you could have two lines that intersect not between them, but on their extension. So to check that, we need to check the intersection point is on the lines, and that's easy. You just get the bounding box of the line, the min and max x's, the min and max y, the min and max z for each line, and make sure that the intersection point is between the max and min, which is something you can see here. I'm checking that the intersection point is more than the min and less than the max. I'm adding the epsilon so that I avoid any mathematical shenanigans. What I mean by this is, imagine that x min is 2 and the intersection point was 1.999. Like for some miraculous reason, there are two lines that intersect at almost the beginning of the first line. You could say that they intersect, so we need to deal with this mathematical inaccuracy. And what I do is I add to it an epsilon and check if it is more than the x minimum, for example. So this addition and subtraction of epsilon is due to the limitation of computer mathematics and computer arithmetic. So I check if it's on line 1. Now this if statement has an else statement, because if it is not on line 1, then here the intersection point is not on line 1 and you can continue. And then you check if it's on line 2, and if it's on line 2, then we found the intersection point and we're going to do something with it here. So here we need to do something here. So here we need to do something. I will tell you exactly what we do here. Otherwise, it's not on line 2, so game over, you can continue. Now we reached at a point here where the point that we have found is, first of all, valid. So it's not on the skewed. Second of all, it is within the line 1. And third of all, it is within line 2. So now it's time to define it. Since I found the node, or I found the intersection point, and it is valid, now I can define an str node that covers this intersection because it exists. You could add some extra logic to the intersection. For example, in the beginning, in the very, very beginning, oh, that's a lot of code we coded. In the very, very beginning, you could, for example, make a condition here that it only searches for intersection if the lines are perpendicular. You can do that by saying dot product equals 0. This is the signs of having perpendicular lines. However, I keep it for everything. So whatever the line orientation is, if they intersect, they will produce a new node. And producing a new node, they shall. So I'm doing this here. Controller dot, oh wait, it's not the controller, it's called object here. Object dot add str node. See how easy it is to reuse my code because I programmed it well. So here I can use x11, y11, and z11, or x22, y22, z22. Doesn't matter because they are the same point. I checked that. Now here it will, the good news are that if this node has been defined, then remember, add str node will not add a node because it's already defined, so there is a duplication check. So I think we have arrived at a very, very, very good milestone, and now we need just to do a quick check. So here in the sample frame, I'm going to add me some things. Let me open the sample frame. I'm going to add me a node 6 or node 5 here, just for funsies. I'll just try that. Node 5 equals the controller.add str node, and I'm going to add it at 5 in the x, 10 in the y, and 0 in the z, okay? So now I added a node. Let me add node 5. I want it to intersect it cannot intersect all 3, right? I want it to intersect 2 of those members. So let's add node 5 at -1 in the x, and 0 in the y, and 0 in the z. And then add node 6 at, let's see, dot add str node. And this one will be at 5 in the x, 10 in the y, and 0 in the z. And I'm going to add me a line here. So controller.add str line, and I'm going to add it between node 5 and node 6 because I want to see if the software detects the intersection. Now, to be able to actually see it, I could let the controller run and show me the new nodes. As a matter of fact, let me do it without graphical output first. So now I have 6 nodes, but I predict that 2 nodes will be generated from the intersection if everything works right. Now, usually when I click the run button, nothing works because that's my first pass of coding. It seems it worked. That's a new thing. Let's take a look at the number of nodes. I have only 6 nodes. What a shame. There should be 8. Okay, there is a bug, it seems. That's pretty cool. That was expected. So let's open the viewer and see exactly what happens. And push F5 now. So let's take a look. Maybe I messed something up. Oh, wait. I messed the definition up? Totally messed the definition up. Okay, what gives? Let's see. I think I messed the definition now. Oh, yeah. It's my fault. Okay. We're still in the game. We are still in the game. I think I messed up because I should have, yeah, it's the z-axis, right? This should be in the z-axis, not in the y-axis. So we're still in the game, ladies and gentlemen. Let's try it again and hope that I see 8 nodes. So let's run. I think I saw 8 nodes. Let me just check. 7 nodes. Should be 8. Let's take a look on the model. Okay, so it sees the intersection here between this and this, but it doesn't see the intersection between the vertical line and the inclined line. Maybe the vertical lines are problems. Wait, give me a sec. Let me try something else here. Let me change this. I just want to identify if the vertical lines are the problem. Let me change this to become, let's see, 11. Now this should intersect the third line and the second line. So let's run again. Run the main and see what happens. Same thing here. He finds the intersection here, but it doesn't find the intersection here because he gives you only 7 nodes instead of 8. Okay, so that's a problem. We need to debug it, right? Now I wanted to have a debugging session for later, but since we are here, let's debug the code. Okay, now I will just first of all put it back to -1 because I want the check to be with the first line. So let's put it back to -1 and run again. It shows this node but doesn't show this node. Yeah, there should be a node here. Why? Well, there's only one painful way to find out. Let's go here to the STR controller. It might be a big blunder, it might be a subtle mistake. There's no in between. So let's put here a breakpoint and let's run the main and see what happens. Okay, so it reaches here and it starts checking. Let me close the view. Oh wait, let me kill the viewer because don't need it, just takes too much performance. So let me eliminate the viewer and run again. Okay, let's see. So now I want line 1 with line 4, the intersection, right? Right. So let's go, step in, and he gets line 1 now. Okay. I think so. Step in. That is now, let's hover over it. This is line ID number 1. Fantastic. Now here I'm going to put a breakpoint, and I'm going to continue. This is line, wait, let me just put the breakpoint here and continue. This is line 1 again. So you skip it. Let's continue again. This is line 2. I'm not interested. This is line 3. I'm not interested. And this is line 4. Now, for some reason, he is unable to intersect them. For some reason. Why is that? Okay, let's take a look on the definition of line 1. I think I can double click here to see it. Those are the local values, like my watch list. Can I see it? Okay, it's opening it for me, it seems. Okay, let's take a look. So wait, what? It doesn't make any sense. No, line 2, right. Line 2, which is line 4 in this case. ID is 4. Its Vx is, let's see, 0.51. Yeah, it makes sense. A little bit of x, more in y, and z. This is the perpendicular stuff. Okay. CG is at 2 and 5. 2 and 5. Why? 2? I don't get it. Okay, what's node 1? Node 1 is -1, 0, 0. That's true. And node 2 should be 5, 0, and 10. That's also true. So it seems it checks out. Okay, fine. Let's take a look. Let's continue our investigation. So we step and he checks. It's not the same line, so he continues his checks. Now he does the cross norm. If they are parallel or not. Now they shouldn't be parallel. So the cross norm should not be 0. And that's the case. The cross norm is not 0. So it's not parallel. So far, so good. Now oh my God, don't tell me the arrow is here. This is the worst place to have an arrow. Now he does his magic trick, I guess. Okay, this is line 1, right? Let's put a breakpoint here and just skip through and see. So for line, let me open line 1 also. This is the painful fact of programming. So line 1 is 0, 0, 1. So this should be 0, and that is 0, and that is 1. That's correct. And for its first node, it should be 0, 0, 5. So this is 0, and that's 0, and that's 5. Yeah, that's true. For line 2, I think it was like 0.5, 0, and 0.8 or something. So let's see. That's 0.5 something, and that's 0, and that's 0.8 something. True. And for line 2, for the node, I think it was negative 1, 0, 0, right? So negative 1, that's true. 0 and 0. Wait, what? Wait. Huh? Wait. What gives? This is line 2, right? Right. And the node, this is node 1, right? Of line 2. Wait. I think I messed up. This is line 2. And this is node 1. Negative 0, 0. Okay. Why is this not 0? It's 0, right? Oh, okay, sorry. This is the relic from the last time. I just should have moved forward. Let's see. Negative 1, 0, and 0. Fantastic. Okay, fine. Let's continue. Now we go into the magic stuff. So he checks and checks and checks. That step. Okay, that one didn't work because they are in the XZ plane, I guess. That's why this check doesn't work. C1B2, C2B1, okay. And this is C1A2, A2 A1. So I think this is the check of the, and it works. Okay. So A1 is 0, so he doesn't do that. Then he goes here. A2 is not 0, so he tries his luck. Okay, fantastic. And he finds T1. T1 should be very small. Wait, 1.66. Yeah, so the intersection point is 1.66. That's true. Okay. And for this one, it should be, I don't know, like maybe 0.2. 1, exactly 1. Why exactly 1? What a coincidence. Okay, fine. He gets T1 and T2. Now I'm interested in seeing the points. So X11, Y11, and Z11. So this should be like 1.6 something. My prediction is X11 should be 0, Y11 should be 1.6 something, and Z11 should be 0. Let's take a look. 0. 0. Oh, wait, why? I thought T1 has a value. And B1. Oh, yeah, sorry. 0, 0, 1.66, right? Yeah, there we go. Okay, fantastic. So this is, so far, this is the correct point. Okay, why is this not correct? Let's see. Step X22 is negative 0.48. It should be 0. Why is it not 0? X02 is negative 1. A2 is 0.5. T2 is 1. I don't believe that. It shouldn't be 1. It should not be 1. I blundered something. What a shame. It's a total wash. It's a total mess. So X22 is some magic equation, negative 4.4, and that's 0. Okay, that's 0, that's at least okay. And for that one, that's 0.85. Now, this doesn't work at all. Why is T2 2? Let's put a breakpoint here, stop, and run main again. And then line 4. That's the line we are interested in. Okay, so now here, somewhere here, things go haywire. So let's run, reach the position here. It steps. There we go. We are here now. There is something here. There's a mistake. I think I found a bug. I think I do. I think that is supposed to be X01. I think that's the one. Let's keep investigating. Only one way to find out. Let's just click on continue and hope for the best. Let's remove those. I think it worked. I think it worked. I think it bloody worked. 8 nodes. Okay. Viewer, show yourself. And run. And I think it worked. Yep, it did work. Oh my god, this is the longest video I have ever filmed. I don't know how long it would be, but this is the longest video I have done. Now we have succeeded. Finally, we have succeeded in the line cross-line intersection stuff. And I uncovered a bug in Strato. In the process, I just modified it. This X02 took me by surprise. But yeah, I think we have reached another milestone. And with that being said, I want to end this video here, so I hope you enjoyed it. And before I finish, I want to give a very tedious debugging session shout out to my dear channel members in the contributor level and the helper level, whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as the support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing and commenting, especially subscribing, because it increases the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.